This is our experimental setup for demonstration of Young's double slit experiment, as well as for studying the interference pattern obtained from a single slit. As you can see here, we have an optical bench which is 1 meter in length. Then we have a laser source over here with variable intensity. We have a single slit and a double slit attachment over here, which is mounted on a rider, which is movable on the optical bench. And we have a screen with a millimeter graph paper attached to it, which is also mounted on a rider and is movable. Finally, we have an experimental manual, which has all the details, including the theory, the diagrams of the experimental setup, very elaborate description on how to do the experiment, all the formulas needed to do the experiment, as well as the precautions and whatever comes with the experimental setup. Everything is given in details here in this manual. So now we will start with the experiment. So before starting, we have to ensure a few things. First is that we will keep the laser source at one end of the optical bench, and we will set the slit, whether it's a single slit or a double slit, very near to the laser source, say at a distance of around 10 centimeter. And the screen will be set at the other end so that there is approximately a distance of maybe 80 to 90 centimeters in between the screen and the slit. I'll just do a close-up here. So we can see that this has two slits, which is separated by a separator in between. Both the slits are open right now, but for the first part of the experiment, that is a single slit, I will close one side of the slit and we will observe the pattern on the screen. And then we will open the second slit and observe the pattern due to interference from two slits. If we look closely, we can see that only one slit is open through which the light is coming. The other slit is closed. So we have a single slit. I have opened the slit with the help of this screw over here. And this is the pattern that we obtain on the screen. It's much better visible on the graph paper than on the camera right now. I'll just switch off the light to get a better view. This is the pattern that we have obtained on the screen from interference due to a single slit. We can now mark the central maxima and the alternate bright and dark fringes with the help of a pencil on the graph paper itself, and from there we can calculate different parameters like path difference, fringe width, position of the fringes, etc. So now we are going to open the second slit and we are going to observe the interference pattern that is formed as a result of the two slits. I'm just opening the second slit. You can see there is a shift in the pattern. So if you look closely, you can make out the alternate bright and dark fringes inside the central fringe. This is the pattern from the double slit. So we have to take a pencil and mark all the fringes, the alternate bright and dark fringes, and from there we have to do the calculations as shown in the manual. This concludes our experiment for the demonstration of Young's double slit interference pattern as well as for the single slit interference patterns. Thank you.
Please subscribe to our channel for more such videos. Thank you for watching.